do you get this out of the way?
Hey there.
Hi, how are you?
All right.
Very well. I was.
Come on, didn't go.
Thank you for extending the invitation to this.
It's that time of year, everyone. It's cold, it's cloudy, we can't see the stars from here. That means it's time for another season of online viewing sessions. So hello everyone, and my name is Richard Bell. I am president of the Kalamazoo Astronomical Society. It is great to see you all here tonight. So what we're going to do is we're going to take a little tour of the night sky as seen from Arizona with the remote telescope. And I'll tell you all about the telescope as we progress here throughout the night. So we had approximately 140 people register for tonight's sessions. And so I'm sure we're going to have a lot more people pile in. Hopefully we have lots of people watching on YouTube as well. And we're just going to jump right into it. And as we do progress here, one thing I would like many of you to do, I know many of you are members, but if you are a guest from outside the club at some time during the night in the chat, please put in your name and location and club affiliation if you have one. So it'd be great to find out where people are coming from, because we should have people from all over the country and hopefully a couple Canadians as well. So I will unmute you here at one point, but let me go ahead and switch back to my PowerPoint presentation here. Got to get adept at doing this. And so let me tell you all about the remote telescope. So the KAS Remote Telescope is located in Peishi Observatory, which is seen here. It is a 20 by 20 roll-off roof observatory located near the village of Portal, in a kind of dark sky community for astronomers and bird watchers called Arizona Sky Village. And so the observatory here is owned by KAS member Mike Patton. And some 10 years ago, he offered to give us a spot in his observatory for a remote telescope. And so we, of course, immediately took him up on this. And you can see the observatory here, but on the back of the observatory, where my pointer will be, we'll get my laser pointer on here. Here we go. So we have this little box right there, and I'll show you that up close. This is our S-Big All-Sky 340C camera. So this camera enables us to see the entire sky, not just for constellation viewing or looking for meteors or enjoying the Milky Way or zodiacal light, but mainly to check the weather. So let me show you how to check the all-sky camera throughout the night. I'll try to go back to it from time to time, but let me give you a idea of how to check it on your own, because perhaps maybe you'll see a nice bright meteor. So let me find the appropriate screen here. So that's a good screen to see. And yeah, this Zoom stuff really kind of gets in the way. So we can go to the KAS website here. Let me start you all over. So this is the main page of the Kalamazoo Astronomical Society website. And all you have to do to view the all-sky camera is go to our remote telescope tab here and select the Peishi all-sky camera, and that takes you right to it. So here we go. So this is the sky as of 6:31:45 local time. So that's about 6 minutes ago Eastern time, because it's 8:37 now. And you can see pretty much the entire sky, although it does clip off the northern sky here a bit and a little bit of the southern sky. And right away you might notice this funky structure here. This is a bird perch that Mike Patton put in because, of course, as we reasoned, birds want to have the highest spot to survey the surroundings. And so they kept landing on the dome of the all-sky camera and pooping all over it. So we did not really appreciate that very much. So we made this perch here, put it a little bit higher. And so far, that seems to have worked the trick. We haven't had too much of a bird poop problem since then. And of course, you can see the surroundings of Arizona Sky Village a little bit. This building over here is actually Mike Patton's house. you can see a little bit of the observatory roof right here. And this is like a red light lighthouse at a neighbor, Rick Benno's place. And of course, the bulk of the scene here is the sky currently overhead. So let's take a quick little tour of the currently visible constellations and see what's going on. So of course, up here is north. So north is at the top, so south is at the bottom. East is on the left, so everything's rising here. And west is over here, so things will progressively set behind the mountains over here. And we can see many of the bright stars. We have the stars of the Summer Triangle. We have Vega, Deneb, and Altair. So again, the Summer Triangle. So we have Vega and the constellation Lyra, Deneb in the constellation Cygnus, which kind of goes like this. This is the head right here, Albireo, with at least two main stars marking the wings. It goes out a little further, like out to here and out to here, but you can really see these three here. And of course, the bright ones here, the 5 bright ones, form the Northern Cross as well. And down here we have Altair, the head of Aquila the Eagle. There's kind of like a triangular shaped body here with a wing here, and kind of tail feathers down there. So the swan kind of flies that way, and the eagle kind of flies that way, although they pretty much stay there the whole time. They just will get lower and lower as the night goes on. You get the idea. And you can see the camera here is a little noisy. It always is at first because it gets warm during the day, and gradually it'll cool off and you'll be able to see things a lot better. But over here we have the, I think this is it. It's hard to tell with all the noise, but we have the great square of Pegasus around here somewhere, along with the constellation Andromeda. Cassiopeia is up here. And of course, we have the Milky Way. We can still see a little bit of Sagittarius, or the teapot, along with Jupiter and Saturn. Capricornus is over here, and this is Mars. So that's just a quick preview of what the sky looks like from Arizona Sky Village right now. We don't have any zodiacal light right now, but once we get toward the solstice, perhaps next month, we should see the zodiacal light, basically dust in the plan of our solar system. So back to the screen here, and just scrolling through the chat here just to get an idea of where people are coming from. So so we got people from Arizona. Don't go out there and steal our telescope, okay? And we got people from the Prescott Astronomy Club, I see. That's great. I don't recall off the top of my head where that is. The Lake County Astronomical Society in Illinois. It's great to see you folks here. I did hear from several of you. I did hear from people from the Barnard Seifert Astronomical Society. Oh, we even have people from the Kalamazoo Astronomical Society. Well, that's great. I'm glad to hear that. And we do have people from the Michiana Club, which is probably our closest club. They're in South Bend, Indiana. People from Austin. Some people from Battle Creek, of course, our neighbor, Portage. They're practically next door. Oh, we do have one Canadian, I see, from Montreal, Canada. That's wonderful. So it's great to see all of you. And don't forget, do be sure to tell us where you're from if you haven't already, kind of later in the night. All right. How I have to bring up the participants again, and eventually here I'll unmute you all, but let's jump back to the PowerPoint. And I'm going to start off with the bad news now. The bad news is over the past few days, obviously, we developed a issue with the Takahashi telescope up here. So this is our Takahashi, which rides piggyback on the main instrument here that I'll talk about in a second. And we do believe the problem is with the filter wheel here. This little black thing between the camera and the telescope is the filter wheel that contains 7 filters. I was able to get it briefly working last night. I took like a 10-minute shot of the Cygnus loop, you know, the Veiled Nebula. And then that was it. The filter didn't seem to want to change. And so we had to make some changes here. I had planned to do 3 images with the Takahashi and 3 images with the plane wave, but now we're going to do hopefully up to 6 images with the plane wave. And so that might make some people happy, because last year some people were telling us, you know, why do you bother with that little telescope? How come you don't show us more from the big one? So if that's what you're thinking is, you're going to be happy tonight, because we're going to feature just the big one here, which is working just fine. And so our main instrument is a plane wave CDK20 telescope, which stands for corrected dull Kirkham. It basically has a ellipsoidal primary mirror, of course, 20 inches in diameter, with a secondary that's spherical with a lens group in the back that helps kind of give us a flat field. But you will notice that we do have a little bit of vignetting on our telescope, because we did have to move the secondary back a little bit to reach focus. But when we do our actual image processing, we can use flat field to correct for that. But you might notice a little bit of vignetting tonight. But when we actually process the images, we can get rid of that. So I did mention it's a 20-inch. It is roughly 3,454 meters in focal length, with an F ratio of 6.8. It does weigh a staggering 140 pounds. And of course, it has a carbon fiber truss tube design. And normally the standard model of the plane wave here comes with a Pyrex smear, but we opted for the upgraded quartz smear, which has better thermal capabilities than the standard Pyrex. So this is the main instrument that we'll be using tonight. And you can see all the good stuff on the back here on the business end of the telescope. So here's the imaging train of the CDK20. So right between all the cameras and the scope is the focuser. We use a Finger Lakes Instruments Atlas digital focuser that moves very slowly, very precisely, no image shift, but man, is that thing loud. But it works very, very well. And so the light comes in through here into the on-axis guider. So the on-axis guider is a little different than an off-axis guider. An off-axis guider helps you select stars outside the field, but an on-axis guider lets you select stars from in the field they're actually taking a picture of. And it has something called a cold mirror. So what happens is the visible light reflects off the cold mirror up into the camera here through one of the filters that we use up into the camera. And then the infrared light goes into the Starlight Express Lodestar 2 X2 auto guider. So guiding in the infrared is a lot better because the seeing is a bit better in the infrared as opposed to visible light, and so that does help with seeing. Sometimes there are some objects we can't find guide stars. For example, at least with the Helix Nebula centered, never find a guide star. You have to kind of move it around a little bit to be able to find one.
Richard, you're not sharing your screen.
Uh-oh. So I goofed. Okay, so let me do that. Oh, I forgot to do something too. Guess I should probably, at least Kevin can unmute himself. So I forgot to share my screen again. That's a terrible habit I have. Okay, so let me back up here. I'll just show you the picture here real quick. So we'll back up here. So there's the plane wave. If you missed this, I'll go through it again next month. So there's the plane wave again with the Takahashi that we cannot use. And this is the imaging train again. And here's our the workhorse of the whole remote telescope, the software BISC Paramount. So the Paramount was our mount of choice. We do have an astrophysics mount in our observatory here at the Nature Center, but we definitely wanted the software BISC Paramount ME2 for the remote telescope because it was basically billed as a robotic telescope mount. So how could you go wrong? So I mentioned our telescope weighs about 140 pounds. That does not include the cameras and the Takahashi. So the maximum weight of all the instruments on the mount is probably pushing maybe 180, 190 pounds. I've never added up, or if I have, I've forgotten. But this mount can hold 240 pounds instrument capacity, and we're nowhere near that. And it can hold 480 pounds total when you've got counterweights on there. We do have a lot more counterweights on here now. So it has basically excellent periodic error, which we have corrected a bit. It's very accurate, but the program we use to control everything, called ACP, does have pinpoint technology that puts the object in the center every single time. The mount really doesn't weigh that much, considering how much it hauls, about 84 pounds. And again, it has many other features like belt-driven motors and so on. So it's a very capable mount, and it's also a wonderful shade of red, which we really like. Whoops. Okay. Okay. So we're going to begin with our first target of the night here, and so I'm going to get that started, and then I'll introduce the target for you. So give me just a second here to switch back to my web browser, which I won't quite show you this part just yet. Okay, boy, it is really annoying trying to use the browser with Zoom on, because that little stuff at the top really gets in the way. Okay. So let me get our first target of the night set in here, and I'll give you a little intro to it. Okay, we're off. So let me go back to where I was here. And Kevin, if you want, you can just go ahead and unmute everyone, make sure everyone can hear me so you guys can yell at me. So so our first target of the night here is going to be a very familiar target. I'm sure many of you have looked at this through a telescope too many times to count, but I thought we might start with something a little familiar and then kind of get off into the maybe somewhat unfamiliar. So as you can see, our first target is none other than N27, the Dumbbell Nebula. And so as you know, okay, let's go ahead and mute everyone again. So M27, the Dumbbell Nebula, .5 magnitude, and it's about 1,227 light years away. So I've showed the Dumbbell Nebula, as I'm sure many of you have, to many people over the years, and a lot of people have trouble seeing the dumbbell. So I often like to refer to it as the apple core nebula, because they see that right away. So they immediately know what it is when you say the apple core nebula. And just to remind you, my name is Richard Bell, so I don't like the Dumbbell Nebula. I don't. That name just kind of bugs me a little bit. So here's a rough idea of where the Dumbbell Nebula is in the sky. I'm sure every one of you know this. It's technically in the constellation Vulpecula, the Fox, but kind of right between a couple stars there. We have, it's basically 3 degrees north of Gamma Sagitta, and which is down here.
Richard needs to tighten this up a little bit.
What do you mean? And it's 2 degrees southeast of 14 Vulpecula. Okay, so kind of a little color here. The Dumbbell Nebula was the first planetary nebula discovered, period. And it was found by none other than Charles Messier himself on July 12th, 1764. And so not only was it the first planetary nebula that he found, but it was, of course, the first planetary nebula. And it was William Herschel, the great William Herschel, that was the first to designate M27 as a planetary nebula around the year 1784. And he called them planetary nebulae because through many telescopes at low power, they look like little disks like Uranus. And of course, it was William Herschel that discovered Uranus. So it's kind of so these objects reminded him of his planet. And so he dubbed them planetary nebulae, although they have absolutely nothing to do with planets. And the Dumbbell Nebula got its name by John Herschel in the year 1833, who described it as a nebula shaped like a dumbbell with the elliptic outline completed by a feeble nebulous light. And of course, there are 3 other Messier planetary nebulae. And I could tell you what they are, but I thought it might be fun for a little interaction here. So here's kind of a pop quiz. In the chat, go ahead and see if you can list the 3 other planetary nebulae that are also Messier objects. And the prize will be, I don't know, gloating rights. So I'm not going to send you anything. So let me go ahead and stop sharing here now. And we are currently about, how far are we? We're about basically halfway into our 5-minute exposure of the Dumbbell Nebula. And we'll see if we can meet, kind of meet a few people here tonight before we finish our object here. Okay, let's see. Oh, I got to get rid of the... So hopefully everyone should be unmuted. If you do have people, walk into the room and talk to you or make some kind of noise, please mute your sound right away so we don't have any more kind of little outbursts like that, although outburst is probably a bit exaggerated. I forget how to have people like raise their hand, but there's a way to do it like digitally, but just kind of surveying through the crowd here. So of course, a lot of you aren't quite sharing video, but so where's our guest from Canada?
Usually you just move this around.
Oh, so that's Don Marie Sullivan. So you're from Montreal. Oh, that's great. So we do have one Canadian
and a
here.
little box pops up and then you can clap.
Okay. Oh, I can hear Dick and Jackie talking. So
oh, sorry.
I'm going to mute you. So it's great to see everyone here tonight. And let's see. Okay, we got one. So Lloyd Simmons mentioned M57. I mean, that's the easy one. But it does look like Mohammed got all the right answers. He mentioned the Owl Nebula, which is M97. So that's one. There's the Little Dumbbell Nebula, which is M76. And then Lloyd got the other one. So I did not see anyone that got all 3 of them here, but between the 2 of you, you got all 3 of them. So yeah, there's M57, the Ring Nebula, of course, M27, the Dumbbell Nebula, M76, the Little Dumbbell, and M97. Out of all 110 objects, only 4 of those are planetary nebulae, and it's those 4 right there. And of course, if you look at objects like NGC 7027 or the Blinking Planetary, I always forget the designation of the Blinking Planetary. Those are objects that look like through most telescopes like planets. So they really show you why they're called planetary nebulae in the first place. All right, so it looks like we're done here. So let me show you where we're taking the pictures at. So we're going to switch over to the program here. So this is the web interface. Oops. The web interface for ACP, or the Astronomer's Control Panel. And woohoo. And so this is where we control the telescope from. So ACP really is a program that controls the programs that control the telescopes and the cameras and the filters and the filter wheel and all that sort of thing. So it doesn't connect to the telescope directly. So we use the Sky because we do have a software BISC mount. We use the Sky X to point the mount, and we use Maxim to control the cameras. So you saw the little message pop up there that says our exposure is complete. So we'll click on the thumbnail here. And here's our first image of the night. Ta-dum, kind of unveiling like behind a curtain or something like that. So there it is. So there's the Dumbbell Nebula, or I'm sorry, the Apple Core Nebula. I forgot. We were supposed to use the better name for Richard anyway. So we'll keep this up here for a second. And one thing I might do is, of course, this is just kind of a low resolution thumbnail. But if I can get the time, as we're doing another exposure, I'll go into our cloud account. I'll download the full resolution version of this, and we'll take a look at it up close and kind of zoom in on the dumbbell here, because this is as close as we can get with our thumbnail preview here. So while we're gawking at it, let me just tell you a little bit about this thing. So when observed from Earth, M27 appears along its equatorial plane. So and that kind of came out a few years ago. If we could view the Dumbbell Nebula from more, say, this way in space, it would look like the Ring Nebula. So the Dumbbell Nebula is the Ring Nebula, but from the side. So they appear to be very similar in structure. We used to think of them very differently, but with some planetary nebulae, it really depends on what angle you view these things at. This thing has an age of about 15,000 years old, which is pretty typical. Planetary nebulae don't last that long, maybe tens of thousands of years, maybe as much as 100,000. But as the cloud around them expands, they dissipate into the interstellar medium there. So these objects are really kind of fleeting in terms of astronomical time. And but the thing is, of course, most stars in the sky become planetary nebulae. So that's why we see these things all over the sky, even though only 4 of them are Messier objects. And so, in fact, the Dumbbell's shell of gas is expanding at about 17 miles per second, or if you're from Canada, about 31 kilometers per second. Did a little conversion there for you. So it does have a white dwarf in the center, which is fairly easy to observe through a telescope. As many of you know, the white dwarf at the center of the Ring Nebula is difficult to see, but the one in M27 is a bit easier, and I'll kind of tell you why. So this one here is about 13.8 magnitude. And white dwarfs are pretty hot compared to stars like the sun, but nowhere near as hot as neutron stars. But the white dwarf here has a temperature of about 153,000 degrees Fahrenheit, or about 85,000 Kelvin. So for comparison, the surface of the sun is about 5,800 Kelvin. So 5,800 versus 8,500. So this thing is very, very hot. And so it probably is literally not really white. It's probably actually more blue if you could see it up close because it's so hot. And it does have a 17th magnitude companion separated by about 6.5 arc seconds, or about 2,500 AU, that was discovered in 1970. Now, what's really unusual is typically white dwarfs are about the size of Earth, right? But not this one. So let me, real quick here, let me switch back to the PowerPoint show, which I'll have to do a new share here, I think. So I'm sure you can't see this yet, right? So someone holler at me if you can't see this. So let me just tell you about how these things form. So we all know that stars in their cores fuse hydrogen into helium, and they basically do this to generate energy to counteract the inward tug of gravity. But of course, they only have so much hydrogen to work from. So when all the hydrogen is gone, for a time, the core becomes a big mass of helium that does nothing but get denser and hotter through pressure. And so gradually the star begins to contract, okay? And so what happens is as the helium core gets denser and denser, a shell around the helium core gets so hot, it begins to fuse hydrogen in the helium itself. And so like on this previous slide here, it becomes a red giant. And as it goes through these alternate stages of expansion and contraction, cutting out a lot here because I could go on forever and I'm not going to, every time it expands into a giant again, it expels layers of itself into space until the core itself is exposed. And by this time, the core is basically carbon, oxygen atoms that just basically give away heat through compression. And so most white dwarfs are probably about the size of Earth, but not this one. The white dwarf in the Dumbbell Nebula is about 6 times the diameter of Earth. So that's huge for a white dwarf, but it has a mass of about 56% that of the sun, which really isn't terribly heavy. Many white dwarfs are roughly about the mass of the sun. So let me again switch back here, and we'll just take one more peek at it there. There we go. So there's the Dumbbell Nebula. Not too bad, right? And so, of course, this will download to our cloud account, and we'll try to go back to it later, maybe look at a little more detail if we have time. But definitely, I will give you a link at the end here where you can download all the high-resolution images yourself and check them out, because I doubt we'll have time to look at all of them. So we're going to say goodbye to the Dumbbell Nebula, our first target of the night. All right, so our next target is another nebula, but a little bit different. And I'm just going to type it in here. We'll show you how ACP works here. So this is the section where we can do single imaging. And I'm going to do NGC 6888. Now I can hit get coordinates here, and it looks up the coordinates for you, but it never frames it quite the way that I like. So I kind of made a note of where I want it to go to. So, well, 12 is pretty close. So we're just going to move it ever so slightly. So 14,207, although it's not that important. Okay, so 38, 20, 12.32. Okay, so that'll frame it a little bit better. And this time I'm going to go a bit longer. So we're going to do 10 minutes with the hydrogen alpha filter. So we're going to go ahead and fire off there. So, oops. All right. All right, so I'm getting warmed up here. Of course, we haven't done this in several months, so I'm a little rusty. So here's our target that we're going to work on now. So we got plenty of time before we get an image of this one. So it's NGC 6888, the Crescent Nebula. And so this is also in the constellation Cygnus, or well, of course, the last target was in Vulpecula, but this isn't terribly far away, at least in the sky, in Cygnus. So as you can see here, the right ascension declination here, that puts it in Cygnus. It's roughly the same magnitude as the Dumbbell Nebula, but it's a bit larger. And this one's about 5,000 light years away. So the Crescent Nebula, in addition to being NGC 6888, is also Caldwell 27 in the Caldwell catalog from Sir Patrick Caldwell Moore, who often just went by Patrick Moore, but Caldwell Moore was technically his last name. Or you can also call it Sharpless 105. So here's where we can find it in the constellation Cygnus. So we were looking over here at the Dumbbell Nebula in Vulpecula, but now we're just next door in the constellation Cygnus with the bright star Deneb. We have the star Satyr here, and the Crescent Nebula is about 2 3/4 southwest of Satyr, but closer, but what's also known as Gamma Cygni. And as you might have guessed, this was also discovered by William Herschel on September 15th, 1792. So, of course, many of the NGC objects were discovered by William Herschel. But we'll look at some tonight that were not. We did look at M27 that was found by Charles Messier. So here's a bit closer look of where we can find this thing. I'm using I'm using a scan of Sky and Telescope's Pocket Sky Atlas. So if you do not have a copy of the Pocket Sky Atlas, it's a great thing to have at your telescope, whether it's go-to or not. And so let's go ahead and cut the screen here. So while we're waiting, we just started the exposure. What ACP does is it'll automatically look for a guide star for you. And boy, it looks like it found a triple star to guide on, but it seems to be going okay. Hopefully that doesn't confuse the poor little thing. So anybody have any questions that you want to ask out loud or ask by chat? Anybody got any questions about the KAS or the remote telescope or the dumbbell nebula?
Can you show a picture of the scope operating, Richard?
Oh yes, I forgot all about that. Okay. Oh boy. So I'm glad someone mentioned that. So let me go back to share on the screen. Well, let me pop up a window here, and let me tell you how to do this. Okay. So give me just a second here, and there we go. Okay. So I'm bringing this up now. It looks like the green screen of doom here.
Hello.
So we go to back to the KAS website. You go to Remote Telescope and pull up the PEC Observatory webcam. And that brings up the webcam here. And there's the telescope live right now. So, of course, you can go to the website and watch the telescope yourself. Now, of course, we have a new problem here that we did not have last season when we first did these in person. Is over the summer I secured our website, so it's HTTPS, and the video that comes from the computer in the observatory is not secure. So that's why it does say not secure here, and that's because of the video here. So if you use Microsoft's Edge browser or Google Chrome, you'll see a little note down here of how to give your browser permission or give permission to your browser to load these videos. So it's not terribly involved, but it takes more than a couple of seconds. But from time to time, I'll try to switch back to the telescope here. So yeah, so this is the telescope live. You can see we always have a spider web problem. It was much worse than this. We did have it cleaned off recently, but boy, those spiders are very productive, and sometimes some of those webs just pop right back up. But sometimes they're helpful because you can watch the web kind of sway back and forth, because from time to time, the video here will freeze up. With Firefox, by the way, it does it automatically. I have no idea why, but with Firefox, it freezes automatically. So, but if you don't see these things sway back and forth, that means you should probably reload the video. And if anyone's watching the all sky camera, if you do perhaps spot like a bright meteor, let me know. We'll switch over to the all sky camera and we can check it out. So let's hop back to ACP and we'll see how we're doing. Oh, I can't do it that way. It becomes so second nature just to use the little shortcuts and windows here, but you can't do that with Zoom. You have to go through it the hard way. All right, so let's see what's going on here. So so you can see we're doing a 10-minute exposure or 600 seconds. We're roughly about halfway into that now. So of course it gives you lots of information, some of which I'm not quite even sure what it is. So of course like the observatory time, right ascension, declination of where we're looking at, the current azimuth and altitude of the object. So you can see it's about 60 degrees high. It's getting lower and lower on us now, which is sad because I haven't finished my narrowband images of this object yet. I have plenty of H alpha images, so I could use this one, but. And so you can see the exposure in progress here with the filter, tells you over here as well. Of course, you can see it's flashing, guiding. And so right now the scene looks a little choppy because it looks a little sporadic here, but it should be fine. Usually it should be a lot smoother than that, but it's still maybe a little warm out there. And you can see the log window here that basically gives you a bunch of gibberish about the guide stars and what you're taking a picture of and all that sort of thing. And this is where we can enter our single exposure data. We can do more complex images with the color series here, where you can use, various filters and have it work all night long if you want to. And of course, you can see, unfortunately, the picture of the guide star we're using, so you can't see, it looks like a little triplet system here. This does not update, at least not in the browser interface here. All right, any other questions or comments or anything I'm forgetting? I wouldn't be surprised if I forget other things. All right, so I do got one question here. How many members are in your club? That's to me privately, but you can ask everyone. So that's from John. I can't quite read the last name there. I think it's maybe Carter, but it's cut off for me. And so currently, that's a good question. We're very proud of this right now. The all-time high membership, with paid members, is 179. We reached that in 2017. And right now, as of this year, we're at 173. So this is the second time in our history that we've broached 170 paid memberships. And so if you count the families as two, we are at probably about 250, 260 individual people. And of course, many of them are not here tonight. Not too surprising. I'll yell at them at the next meeting. And another question is, how often do you do these viewing sessions? We do them once a month from November through February. So of course, this is the first one of the year. We did postpone from last week. That's probably why the attendance isn't quite what we expected, because we had over 140 people register.
I'll try to find that too.
Oh, gotta mute somebody. And I forgot where I was. So yeah, because maybe we don't have as many people as we had hoped, because we had to postpone from last week, because last weekend not only was it cloudy, but it was very windy. But I did freak out a little bit today. Let me show you why I was kind of freaking out for a bit. Let me switch back to the browser and bring that back down so I can change it. So let me scroll down here from the all sky camera, and you can see the weather chart here. And so here's why I was freaking out today. It was not supposed to be this windy. So for a brief time, the winds shot up over 30 miles per hour. So I was afraid we might have a wind issue again. And normally the red line here is at 10 miles per hour, but I got a little nervous and I bumped it up to 15. But boy, if we had winds about 15 miles per hour, guide stars would be very difficult to keep in, because they knocked the telescope around pretty well. But you can see the winds are dying down very nicely now. And looking at the readout on the observatory computer, the winds are currently at about 3 miles per hour. So it is a great night to do the sessions here. And I will definitely mention later tonight when the other sessions are. And so,
Richard,
yeah. Oh.
with that, with the wind sensor that the graph you just showed, explain the significance to the telescope with that.
Yeah, so if the wind goes over the usual 10 miles per hour, a loud buzzer will go off that you might hear. I'm sure my microphone would pick it up, and the scope would park itself, and we would have to wait for the winds to die down before we could start back up again. All right, could you hear that? Bonk, bonk. That means the picture is done. So I hope I got something. And let's see, where are we going here? Yeah, I want to go there. And I got to bring that back down so I can see. And oh boy, there it is. Okay, I'm done. No, okay, we'll click on that. You have to wait to hear those little bonk noises before the image actually loads, because what happens is when the picture is done, ACP uses Maxim to do a quick little processing, because these are fit images. And if you do images, if you do imaging with like a cooled CMOS camera or a CCD camera, they're in FITS format. And when you first open them, they're totally dark. So of course, this is processed a little bit here. So isn't that beautiful? So again, this is NGC 6888, the Crescent Nebula in H alpha, and I'll come back to that. So let me tell you a little bit about the science background behind this. So the Crescent Nebula is called that because this part here is the easiest part to see through a telescope, because of course it's denser, probably because we view it on edge here, and so it's a little bit brighter than the rest of the portion here. But the Crescent Nebula does have another name that I just found out about today. The nebula apparently looks like the Euro sign, which I did look up today. So people also call it the Euro sign nebula, because the Euro sign, for the currency, kind of has like an arc like this, and like two little dashes going out from there. So there's like one dash at least, whoops, but there's not like a second one. So it's not a perfect version. But of course, in an image like this, you really don't know why it's quite called the Crescent Nebula, because it looks like a big, football or something like that. So I believe right there is the 7.5 magnitude Wolf-Rayet star WR136, or HD 192 163. So the nebula itself measures about 25 by 16 light years. And so this nebula was formed from that Wolf-Rayet star, because these stars have fast, powerful stellar winds, like the sun has the solar wind. So on other stars, we call it the stellar wind, but with Wolf-Rayet stars, they're much faster. And what happens is these stellar winds collide with the slower wind that the star ejected when it became a red giant, or probably red supergiant, about 250 to 400,000 years ago. So in astronomical terms, this nebula is practically brand new. And so we think the star itself, WR136, is about 4.7 million years old and is expected to go supernova within a few 100,000 years. And so this star is a supergiant, and so it is very impressive, even though it doesn't quite look like it from the picture. So this star is 600,000 times brighter than the sun. 600,000 times brighter. It's 21 times the mass of the sun, and 5.1 times larger. And it has a surface temperature of about 70,000 Kelvin. So that kind of puts it up there with the white dwarf star. So there it is. And this thing just has just a beautiful structure. And you can really see that in hydrogen alpha. So, of course, we know about the visible spectrum, Roy G. Biv, red, orange, yellow, green, blue, violet. There is no indigo. And so hydrogen alpha is in the red portion of the spectrum at roughly a wavelength of 656 nanometers. And so when you look at all these emission nebulae, like, of course, the Orion Nebula or the Lagoon Nebula in pictures, and they give off all this kind of pinkish reddish light. That's hydrogen alpha. And so with a hydrogen alpha filter, it just lets through hydrogen alpha light. And so it gives us much more detail than you could see in visible light. We could do a visible light picture of it maybe another time, but it's much more detailed here in hydrogen alpha. And we have the best hydrogen alpha filters you can get. We have the Astrodon hydrogen alpha filter with the 3 nanometer slits. Just that filter, which is like 50 millimeters square, for us was about $1,200. So so that's why we're putting it to use here, because it was a pricey little sucker. And you can see a bit of glow around here. So this is more nebulosity in Cygnus, because we're looking right into the disk of the Milky Way. So there it is, NGC 6888, the Crescent Nebula. All right, one more nebula. So let me go ahead and close this out. Don't forget, you'll have high resolution versions of this maybe tonight, but more likely tomorrow, but I'll do my best. So our next target, I don't need to get rid of the whole thing, is NGC 281. And this time, I don't want to use that one. I want to use this one. I don't want to do all those color images. That'll take forever. So we're going to hit get coordinates there. We're going to do another 10-minute exposure in hydrogen alpha, and off we go. All right, so let's, where were we here? All right, so here's our next target, NGC 281, the Pac-Man Nebula. Waka, waka, waka. And so, so here are a few facts about this from the sketch here. Oh, by the way, I forgot to mention, in all these little intro slides here, I show a sketch that I find online. Unfortunately, sometimes I do these so fast, I forget to give credit. So eventually here, for future years, I'll go back online, try to find this again, and give proper credit where credit is due. So the Pac-Man Nebula is located in the constellation Cygnus, or I'm sorry, Cassiopeia, starts with a C, close enough. Roughly the same magnitude as the other two objects that we were looking at, but a little bit bigger. This one's about 35 arc minutes, so about 5 arc minutes more bigger than the moon. So this is a good sized nebula in the sky, and it's about 9,500 light years away. So here's where we find it in the constellation Cassiopeia, kind of below the W or above the M. It depends on how you look at it, of course. So, of course, everyone's familiar with the W-shaped Cassiopeia. And from very dark sites, very dark sites, like what we have in Arizona, nowhere around here, of course, in the Kalamazoo area, I have read, you can see this with binoculars, but this is an object I've never actually viewed myself through a telescope. So here's a bit closer view of where we can find this thing in the sky. So it's located 1.7 degrees east of Gamma Cassiopeia, or Shadar. I'm probably messing that up, but if someone can give me a better pronunciation, go ahead and impress us. So this was discovered visually with a 5-inch brine refractor by Edward Emerson Barnard, one of the last great visual observers, good old E.E. Barnard, on November 26, 1881. He actually discovered this nebula while he was searching for comets, because back in his day, in the late 1800s, there were people that would pay you to discover comets. So he got basically $200 for every comet discovery. And he was also working on like a $2,000 prize. And so how much did he get paid to discover NGC 281? Nothing. You guessed it. Nothing. Comets were much more valuable at the time, but I personally would rather discover this thing than a comet, than some little ice ball. So they don't quite show it on the picture here, But within the nebula, which we might see, is the open cluster, or IC 1590. And this was discovered by Camille Guillaume Bourgadan, a French astronomer, so I'm probably butchering that as well, with the 12-inch refractor at Paris Observatory. So that's where you can find the famed Pac-Man Nebula. And I don't know if anyone knows, but boy, today I tried to look online or in books that I have in my library here very, very hard. I cannot tell you who named this thing the Pac-Man Nebula. It's obvious why we call it the Pac-Man Nebula, but I could not find who that originates with. So if anyone knows, go ahead and let me know. I'd love to know. Okay, how we doing here? Uh-oh. Let's see. Did I forget to do something? Uh-oh. Okay. Oh, it doesn't look like it's working here. So let me hop back to my browser here. I'm not gonna share the screen here. And did I forget to hit acquire images?
I don't believe so. I thought you did.
I thought I did too. Okay, now it's going for sure, I think. Yep, I got the little siren here, so I must have not hit it quite right. So, oh shoot, there goes some time lost, but oh well. We'll make it up here. So let me go through the questions here. So Don Stillwell, who's our treasurer, asked, how long do you take to plan a viewing session like this? A long time. Of course, it's, the fun part is picking the object I want to look at, because that's what many of us enjoy doing, is making up little viewing lists for ourselves. But what takes time is doing the research to kind of give some colorful background, because of course it'd be easy just to pick an object, take a picture of it. You guys can stare at me all night, ooh, fun. Of course we can chat a little bit. But it does take a little bit of time to do the research. I do have many books here to look at. If we get time, I'll show some of them to you. Some of them are right behind me. See, there they are. That's just a tiny fraction of the books that I have, and of course I look online as well and put all the slides together. So try to make this a little more colorful. Sort of like a planetarium show, but better because it's real. And so another question is, what's the club's investment in this remote site? Too much? So I'll just give you a quick historical background on the remote telescope. So I mentioned it's been a little over 10 years since Mike Patton made the offer to put this telescope up in his observatory. So that was back around 2008 when he actually made the offer, like early 2008. And, at that time, and like now, the economy was in ruins. We had the Great Recession. So one of the local foundations that we often occasionally got money from, the Gilmore Foundation, specifically sent us a letter saying, do not ask us for money. We don't have any. And we were like, well, we're not planning on it right away, but we kept that in mind. And of course, the following year, 2009, was the International Year of Astronomy. So we were busy doing outreach for that all year long, like I'm sure many other clubs were. Many of you were from other clubs around the country. And so the fundraiser itself didn't officially begin until around 2011. And, we made grandiose plans. The original telescope I wanted to get was from RC Optical. I wanted to get a 16-inch Ritchie-Chrétien telescope, but they went out of business. And so we decided to go with the 20-inch plane wave. And of course, I wanted to get the Takahashi. I wanted to get the Paramount. We were going to get the Paramount one way or the other because otherwise this thing would be very difficult to control with, I think, most other mounts. And so I thought we would have to settle for like a 14-inch Celestron, you know, very nice telescope, but we wanted to get the absolute biggest scope that we could put into that spot in the observatory. And so to my surprise, the money just started rolling in. And in total, over the next 8 years, we raised about $122,000. And 60% of that was from club members. So of the $122,000 that we raised in all, 60% was from club members. And there's a video, there's actually a couple of videos on our introductory remote telescope page. If you scroll to the bottom, there's a video down there with all the people that gave us money. So if you did donate money to the remote telescope, hopefully your name is in there. I hope it is, because if it's not, I'm not going to go back and put it in the video. I'm being terribly honest, and I'm really sorry because that video took forever to put together. So Eric Fisher says he always wanted to join the KS, and this tipped me over the edge. So we'll count you as membership 174. I'm looking at my browser here for PayPal payment. I don't see anything yet. So we'll be looking for that. If not tonight, maybe tomorrow. And so John Carter, not the John Carter, right? The one that went to Mars. He just went outside with his Canon 18x50 IS binoculars to look at the Pac-Man Nebula, and too many clouds. So he saw clouds, but not the right clouds, the wrong clouds. All right, how are we doing here? Oh crud, we're only about 3 minutes in. Oh shoot! So next time I better check to make sure I actually press the acquire image a bit quicker there. So anyone else have any more questions or have anything to share? So John Carter, I see a observatory behind you. Is that your observatory? So go ahead and unmute it and tell us about it. Is that live? We can't hear you. I'll have to unmute you. Oh, hang on here. Maybe I have oh, it's up here. Okay, everyone should be unmuted. So John, tell us about your observatory there. Well, we still can't hear you. Do you have your video muted? Doesn't look like it.
Turn your microphone up.
Now you're muted for sure. Let me unmute you again.
Is that any better?
Ah, there we go.
That's it.
All right, good. Yeah, I had you on a remote speaker, which doesn't have a mic. Yeah, that's a 10x12 roll-off roof that I built. It's basically an aero shed, which I have modified.
Yeah, that's been me too.
Yeah, and that's a 14-inch Celestron Edge HD built inside there with a 100 millimeter SVQ 100 on top of it, piggyback.
Where are you located, John?
I'm in Paulden, Arizona, which is about 17 miles north of Prescott.
Okay, so you're up there.
I'm up there. It's just under 5,000 feet where I'm at.
Okay.
Yeah, the shots are taken down at Portal in southeast Arizona, right in the corner.
Yep. So yeah, right. This is southeast looking view that I've got there. And I just recently had all this paving done and put the rocks in, make it look nice. It's in very good shape right now.
Oh, I did remember one thing I forgot to do early on. I was going to mention
Like
that
Walgreens.
everything that we look at is, of course, live from the telescope. But there is one thing I wanted to show you that I acquired last night. It's not a deep sky object. So let me give you. Let me show you what it is here, if I can find it on my screen here. So I'm going to switch over to Pix Insight, and here it is. Ain't it cute? So this is
See,
Comet.
when people do that, you just need to get a shot of it yourself and then just sneak it in there when they're not looking.
Yeah, so here we go. So this is Comet C 2020 M3 Atlas. So right now, this is roughly a 8th magnitude comet moving toward the star Bellatrix in the constellation Orion. So I took the shot last night with the plane wave. So this big fuzzy thing here is the comet. So the nucleus is somewhere down here somewhere, and you can see the large coma around it. I was going to try to put together the color image today, but I didn't have time. But what really amazed me is you can see many galaxies in the picture. So let me zoom in here. So there's the comet. Looks like it maybe moved too much. Maybe 3 minutes was too long. But I was surprised at all the other galaxies that you can see in the picture here.
A long COVID one.
So if I scroll around here, you might be able to
test
spot
I
some
got, the
galaxies.
nurse was wearing the mask over her mouth and not her nose. She deals with potential COVID patients all day long, and she's just breathing it in.
So everybody see the comet there?
Yeah, I
All
saw
right.
that.
Great. How we doing here? Okay. Got a little more than 2 minutes left.
Hey, Richard, that coma,
Oh
is
my
that's
God.
bigger than the full moon, correct?
Yeah, I'm not sure.
Real?
It looks like it. It doesn't quite feel the field, so it must be pretty close. But I'm not quite.
I thought I read it did.
It wouldn't surprise me. So somebody asks, is this your day job or hobby? If everyone gives me money, it could be my job.
What? Wait, I thought you said it wasn't real.
So no, this is my hobby. Of course, we're all most of us are hobbyists. I did used to teach astronomy. I am doing a course here online pretty soon that I'll tell you about later. And how did you go about building your knowledge base?
Well, yeah, that's exactly why I wear one.
Reading. So like anyone, I read. So back when I was a kid, of course, there was no internet. So I just read a lot. Okay, we're gonna mute him there. Yeah. So when I was a kid, of course, I couldn't go to dark sky. So most of my childhood was spent reading. So that's how I recommend anyone get started. Read. My absolute favorite book was Peterson's Field Guide to the Stars and Planets. That book taught me everything. I think we're almost done. So let's go ahead and catch the final seconds of our exposure here. Where am I? I lost track of where Firefox is.
Hey, Jimmer,
Oh, here it is.
good old fashioned.
Still don't see any payment in there. Okay, never mind. All right, so we're just about done here. So you can see the scene has gotten a bit better. At least it was. Looks a little choppy here, but that's okay. And we're almost done. The suspense is killing me. We'll peek down there. 5 seconds. Oh boy. I don't know why it goes 5 seconds past. That's weird. All right, it's done. So it has to download to the computer. ACP will do a quick processing job with Maxim, and then it'll upload the image to the web browser here. And so we should see it pop up. So there's the thumbnail. Now we have to wait for the little bonks. There's one bonk. There's two. All right, so we got the little pop-up, so now we can view the image. I like how it unveils slowly over time. There we go.
Oh my gosh.
So that's beautiful. So so this thing has dimensions of 96 by 82 light years.
What?
It's a good sized
I know,
nebula.
he has the Pac-Man nebula up here. It's just gorgeous.
And so this does contain the cluster IC 1590, which is about 60 to 70 stars. I think it's probably right around here. Of course, in H alpha, it's not so prominent as it would be in visible light. And the cluster here is about 3.5 million years old, and it's about 17 light years itself. And deep inside the cluster, you can probably see this dense concentration here. That's HD 5005, which is very much like the trapezium in the Orion Nebula. It's basically 4 type O stars, you know, very hot stars that give off a great amount of ultraviolet light. And it's this group of stars here that's responsible for lighting up this entire nebula here, just like the Orion Nebula with the trapezium. And so all the gas here, the total molecular gas content is about 20,000 times the mass of the sun. What is that? Mute, Kevin. Okay, so we muted all the participants. That was interesting. Okay, so the really neat thing about this nebula is that it is located off the galactic plane. Most emission nebulae, you know, are right in the spiral arms, you know, even like right at the front of the spiral structure, because that's how they form through something called the density wave theory, but we'll maybe save that for another time. And but this one's like 300 parsecs, you know, well over 1,000 light years below the Perseus arm. And we think the reason why this is not in the plane of the galaxy is that this may compromise a super bubble formed 17 million years ago by gas driven off the plane of the galaxy by a supernova and winds from various OB association of stars. You know, basically a OB association. It's kind of like an open cluster, but they're not bound by gravity. So associations are like open clusters in every shape and form, except they're not bound by gravity like stars in an open cluster. So you can see some really nice structure here in H alpha, which is why we chose to use this filter. So it's this kind of wedge of dark nebulae here that gives the Pac-Man Nebula its name. But of course, probably in 100 years, you know, no one's going to know what Pac-Man is, and they're going to wonder why we called it the Pac-Man Nebula. But you can see a nice pillar, like the famous pillar in M16 right here. Some dense clouds. I'm sure there's some star formation going on in this kind of Bok globule here. This small, dense, dark nebula, which we call a Bok globule, named after Bart Bok, the guy that studied these things. So there it is, the Pac-Man Nebula. All right. Next. I lost track of my PowerPoint. Like, oh, I got so many windows open here, I can't find anything. Okay, so next up, this will be a lot quicker, is we're gonna do into the Aquarius cluster. So I figured we had to do at least one globular cluster because they're my personal favorite. So before I jump off here, let me go ahead and get this thing started and make sure I actually do start it this time. But this time we're going to do a much shorter exposure. So I'll try to do it at 2 minutes with the luminance filter. And maybe I'm hitting it too hard. There we go. Okay, now it definitely started. I think I'm trying to hit the acquire image too hard. I'm just getting too excited. We're just having too much fun here. At least I hope you guys are. Okay, so yeah, so M2 technically doesn't really have a name, at least not a popular name, but it is in the constellation Aquarius, so why not call it the Aquarius cluster? And so this one's much more distant than what we've looked at so far, but as you can see, it's a bit brighter. So we'll see why. So it's about 6.3 magnitude, not like 7.5, about 16 arc minutes across, and it is a whopping 55,000 light years away. And so we can find it right about there in the constellation Aquarius, the water carrier. In fact, this little kind of Y-shaped group up here is called the water jar. And this is where we can find this thing in Aquarius. Here's a bit of a closer look here. So this thing is located 4.8 degrees north of Sadu Sud, or Beta Aquariae, which is right there. So just north of there. This one was discovered by the Italian and French astronomer Giovanni Domenico Maraldi, along with M15 around the same time, September 11th, 1746. So Giovanni was born Italian, but he moved to France and changed his name to Jean-Dominique Maraldi. So you can either call him Giovanni Maraldi or Jean-Dominique Maraldi. Take your pick. And so Messier added this to his catalog September 11th, 1760, exactly 24 years later. I think my math on that is right. No, 14 years later. Sorry. So yeah, so Messier added this to this catalog 14 years to the day that Maraldi discovered this thing. And now Messier, he likely used a telescope, very small, which he often did, a small refractor, because he described this as a nebula without stars. And we'll see how just wrong he was here. And William Herschel, you know, the great William Herschel, also observed this with his 4.2-inch sweeper telescope in 1783 and wrote that it looked like a telescopic comet. So I often say that it's M2 that gave Messier the idea to start his famous catalog of objects to avoid, you know, objects that look like comets but weren't comets. Of course, M1 was the first one. But, you know, with the first one, you just say, well, it looks like a comet. I'm going to chart it, and I'm going to move on. And then he comes to M2, and he's like, here's another one. Okay, that's it. I'm going to make a catalog of these objects that look like comets, but aren't. So for me, it's M2 that started the entire Messier catalog, even though M1's the first one, the Crab Nebula. So to both Messier and Herschel, you know, it just looked like a nebulous blob. But in 1794, using a 6-inch telescope, Herschel did say that it looked like a cluster of stars, many of them visible. So with a 6-inch telescope, it does a lot better than Messier's small refractor or a small reflector. But then John Herschel, the son of William Herschel, using the 9-inch telescope in 1830, described it as a heap of fine sand. So I propose that we can also call M2 the fine sand cluster, which I think is a very good name for a globular cluster like this one. All right, so let me switch back to the web browser. And we're only doing a 2-minute shot of this one. So this time it'll go a lot quicker. We'll pick up some time here, and we'll get to see it in all its wonderful glory. Check out the winds here. So right now the current wind speed is measured to be 3.4 miles per hour. So thank goodness. I was worried it was going to surge back like it did earlier today, because it kept coming back and back, and I'm like, uh-oh, that's not good. But we really got lucky there. All right, so it finished the exposure, and I heard a little tweak, so the little beep, which means the guiding is going to cut off. The image is going to have to download. It'll get processed and then it'll get uploaded. So it takes a little time here. And look at that, right in the center. So with Pinpoint, it puts it in the center every time, but the Paramount usually gets it in the field of view. But Pinpoint with ACP centers it every time. So we'll go ahead and click on that one there. And there we go. So yeah, wouldn't you say the fine sand cluster is a great name for that? So M2 is cataloged as a class 2 globular cluster due to its dense compact core, because you can see it is quite compact and quite dense. And it is one of the largest and richest known globular clusters. It's about 175 light years in diameter and contains between 100,000 and 150,000 stars. I'll go ahead and take a minute so you can count them. Okay, go ahead. Are you done? Okay. So the brightest members are red and yellow giants. And of course, as with many globular clusters, it is old. This one measures at about 13 billion years old. So it is one of the older globular clusters associated with the Milky Way. And there's often said to be a possible dust lane along its northeast quadrant. So I think north would be more or less at the top, and the image is often flipped with the, it's always flipped with the on-axis guider, but where exactly the dust lane might be in the picture, oh, there it is. So that it does look like there could be something here blocking stars, but this would be very unusual because globular clusters don't really contain much in the way of gas and dust, aside what maybe some of the stars belch out from time to time. But we've never seen a star forming region in a globular cluster. So these objects obviously made all their clusters or all their stars at once billions of years ago, used up all the gas and dust, and that was it. They were done. So that's why all these stars here are old. There's no new ones to take their place. So if you don't know much about globular clusters, here's a quick breakdown for you. Switching back to the PowerPoint slide here. So of course, like with most globular clusters, they're not in the disk, this green thing of the galaxy, the Milky Way, but they usually are in what we call the halo, which is composed of basically old red dwarfs, some white dwarfs, but mainly globular clusters, which is what all the little red splotches are. So these globular clusters, they can pass through the disk or the central bulge of the galaxy, but most that we see are either above or below the plane of the galaxy. So M2, it's about 55,000 light years away. So if the sun were like down here, say this star here, M2 would probably be quite a ways up here, maybe about here or so. Not maybe quite up here, but probably down here somewhere in this area. And so they have great elliptical orbits about the center of the galaxy that take hundreds of millions of years. Of course, the sun itself takes about 200 million years to go once around the galaxy. So globular cluster stars could take, at least 200 million themselves, but probably more. So there we go. So there is M2, the Aquarius cluster, or you can call it the fine sand cluster. We'll get that started here tonight. Oh, and I was going to mention, I did learn something new about this. This is part of something called the Gaia sausage. Very nice astronomical name there. This is a hypothesized remains of a merged dwarf galaxy, and along with 7 other globular clusters. So there is a distinct possibility, very much like Omega Centauri. You may have read that Omega Centauri, a very magnificent, large globular cluster, but only because it's pretty close, may be the nucleus of another galaxy. The same could be true for M2 here. But if M2 were the same distance as Omega Centauri, it would take up a huge chunk of the sky, because this thing is much, much larger and denser than even Omega Centauri. Omega Centauri is so impressive because it is relatively close to us. So there we go. All right. So the next target, we got to do some galaxies now. So let me type in NGC 891. We'll hit get coordinates. Whoops. My 8 key is sticking again, so we'll try that again. We'll try about 5 minutes with the luminance filter and just click it very nice and gently. There we go. Now it worked right away. So I am definitely hitting it too hard. So we'll switch back here. All right. So, oh, I keep forgetting to hit the next slide there. So our next target is NGC 891, the Silver Sliver Galaxy. Notice I said that slow because if I said it fast, I'd probably stumble right through it. So this is a very cool galaxy, amongst my favorite type of galaxies, one that we see edge on, as noted by the sketch here. So I kind of gave it away. And so it's much fainter than anything we've seen so far, but only about roughly 11th magnitude. That's not too bad. But this one's a whopping 27.3 million light years away. So this is by far the most distant thing we've looked at so far tonight. In fact, I think it is the most distant thing we will look at tonight. So here's where we find it. In the constellation Andromeda. For a minute there, I always think it's above Andromeda, kind of near the Andromeda galaxy, but no, it's out here. So you can just kind of follow from Alpheratz, this arc of stars here, and it takes you right to it. So that's kind of a little star hop trick for NGC 891 there. And this is also known as Caldwell 23. And Stephen James O'Meara, who I own many of his books, more than any other author really, nicknamed this the Outer Limits Galaxy because apparently it was featured in the series premiere episode, The Galaxy Being, in 1963, but I've never seen that show at all. So maybe I can find it on YouTube. And so it was discovered by William Herschel. There he is again on October 6, 1784. But many sources may list it as being discovered by Carolyn Herschel, but nope. Her brother William Herschel was the one to discover this. But we'll talk a little bit more about Carolyn here shortly. And it is located about 3.5 degrees east of the fine double star Gamma Andromedae, or Almach, right there. So there's Almach right at the end of that arc of stars in Andromeda, and just 3.5 degrees off is where we find NGC 891. Very, very nice galaxy. Kind of hard to observe visually, at least with the skies we have around here, but it is a very neat target because I've always been a big fan of edge-on galaxies. So let me go ahead and stop sharing the screen here for a second and see if we have any more questions in the chat here, or we can kind of unmute everyone and people can ask questions. So so is the wind more of an atmospheric disturbance issue or a shake in the optics? Do you mean the local wind, Eric? Okay, I'm not sure I quite get that.
Well, that's what I was just thinking. Like does it shake the telescope more, or is it that the atmosphere is more disturbed?
Yeah. Well, when the wind gets around 10 miles per hour, it does shake the telescope. You can see that in the guide star, but I can't show you that right now because number one, there's no wind. So that's good. I don't want to show you that. But yeah, the wind can knock the telescope around quite a bit. Quite often the scene is pretty good there. And I haven't checked my email yet, but thanks for the payment in advance. I'll send you an email. So we're at 174 now. We're only 5 away from tying our record. Anybody else have any other questions or anything? You can ask in person if you want. We got about, we're not quite halfway in yet, but we're getting there. We're almost at 2 minutes. It's guiding the way. Let's check the all sky camera. Let's go back to the browser here. Bring that down because I can't get to the tab. And so doesn't look like I see any meteors. We definitely need to clean the dome a bit. The dome hasn't been cleaned all summer. Our telescope is shut down during the summer because we have the monsoon season with frequent lightning strikes. In fact, one of our neighbors, David Churchill, his observatory had some major issues with lightning. And so he had to do some repairs after the monsoon season. So that's why we unplug everything over the summer. And we just make do, with the new telescope in our observatory. Because we just got a new telescope here at the Kalamazoo Nature Center in town. We have a 16-inch Meade with a 4-inch teleview on an Astrophysics 1600 mount. So it's a very good setup. And scrolling down here, yeah, the wind's really flattened out. Looks like it might pop back up again, but hopefully it'll stay under that 10-mile-per-hour mark. It's supposed to the entire night. So that is the good news. And we can even check in on the telescope. I think that's live. I have noticed that the video does seem to pause, but the cobweb still moves. So maybe it does like a loop thing too. I don't quite get that, but that looks pretty accurate. And you can see our logo here. Thanks to Rick Benno, Mike's immediate neighbor at Arizona Sky Village, for making that for us. He also made us one for our observatory here in town that I still need to get mounted. This little funky box here, that's our flat field box that I still need to set up. I still got to get the telescope to where it points at the flat field box so we can do flat fields and get rid of that vignetting. And this is a reflector for the sensor that tells the roof that it is safe to close. Right now, the infrared light from our webcam is reflecting off the reflector, so that's why we have that glow there. And oh, how I wish we could use the Takahashi. So hopefully once Mike Patton gets there next week, he can take a look at that. And it could be moth issues, but I don't know how they would get in there. We had a web switch, basically a power strip we used to turn everything on and off. That died on us, but once we cleaned out the dead moths, it worked fine. But that's after we bought a new one. So we have a spare now. That's nice. And we're almost done. So let's head back to the web browser. Whoops, I can stay right here. I think no, I have to switch. Here. Scroll back. All right, right on the money. Look at this, so you can see the graph is much smoother, so the scene is really improved. Of course, we're looking fairly high. There we go. And there's one bunk, 2 bunks. All right, so that means it's done. And we get the little pop-up. Beautiful. So I do love me some edge-on galaxies. So this is a spiral galaxy, but it is tilted a mere 6 degrees from being perfectly edge-on and is oriented northeast to southwest in the sky. This one measures 110,000 light years in diameter. So about maybe 10,000 light years longer than the Milky Way, and has a mass of about 150 billion suns, which is pretty typical of a galaxy because it's made of probably 400 billion stars, but many of those are very, very light compared to the sun. So we do think that NGC 891 may be what we call a barred spiral galaxy, where you have these bars that extend from the central bulge of the galaxy and then branch out into spiral arms. So, because normally when the nucleus is kind of elongated like this, that's typical of a barred spiral galaxy. But of course, we're not 100% sure because we can't view it face on because we would have to travel tremendous distances to do that. So we'll have to just pretend we have a pretty good idea that we know what it looks like. And so NGC 891 is a member of the NGC 1023 group of galaxies in the local supercluster, which we are also a member of. And it contains 14 members, 14 known members. So the Milky Way belongs to the local group of galaxies, which of course includes the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy M33 that we're going to look at next month. And so this cluster, the NGC 1023 cluster, contains only 14 members, but I'm sure there are many faint dwarf galaxies that we can't see because most of the galaxies in the local group are also dwarf elliptical galaxies. And so evidence suggests that, like the Milky Way, NGC 891 here is surrounded by a massive halo of dark matter. And we know that, we're pretty sure of that because what happens is, you expect stars to orbit the galactic center that are close in, very fast. So stars here orbit very fast. But stars on the edge should move a lot slower. But what we find in the Milky Way and other galaxies is stars toward the edge of the galaxy move a lot faster than they should. So that tells us there's unseen matter beyond the edge of the galaxy. We can't see it. It doesn't emit light, reflect light, or absorb light. So we call it dark matter because we don't know what it is. But it doesn't emit, reflect, or absorb EM radiation, light in any way. So there we go. That's NGC 891. So beautiful dust lane that kind of divides the galaxy in two. And they do call it, the silver sliver galaxy, but when you do see it in images, it has more of a golden color to it, color images, because of course our cameras are monochrome. We have to use, RGB filters, red, green, blue filters to make the color images. And of course, doing something like this, we don't have time for that. That would take forever. We'd barely get through one object a night if we did color. And monochrome cameras are much higher resolution than your standard color camera. So that's why we have a monochrome camera. All right, so our last target of the night. So let me get that out of the way there. Well, I should say this is my last planned target. If we have time, we can take a request or two. And so NGC 253, we'll do 5 minutes of that and just gently hit that, and off we go. Okay. Okay, so again, our final planned target of the night is one of my absolute favorite objects in the sky, NGC 253, the Sculptor Galaxy. So it's in the constellation Sculptor. And this is also known as the Silver Coin Galaxy. You'll see why shortly. And this is about 11.4 million light years away. So closer to us than NGC 891. So 891 will definitely take the title of the most distant object of the night. But hopefully in future sessions, we'll try to go a little bit further. So let me give you an idea where this is. Sculptor is a pretty obscure constellation. It is difficult to see from around Kalamazoo, but if you're a little further south, say Arizona, this will be a little higher for you. So Sculptor is a very faint constellation right below Cetus the Whale. Cetus is a bit easier to see than Sculptor, but even Cetus can be a little on the challenging side. And so it is located about 4 3/4 degree northwest of the 4th magnitude star Alpha Sculptoris, right there, and 2 degrees northwest of the South Galactic Pole. So the South Pole of the galaxy, as projected into space, is right near 253, right there. And so this object was discovered by Carolyn Herschel in the year 1783 while looking for comets, because she was one of the most prolific comet discoverers of her time, if not the most prolific comet discoverers of her time. So Carolyn Herschel here was born in Hanover, Germany on March 16th, 1750. She is the 8th child and 4th daughter of Isaac and Anna Herschel. And she was struck with typhus at the age of 10. So she was very ill, and this stunted her growth. She never grew taller than 4 feet 3 inches. So she was a pretty tiny person. And because of that and other reasons, she was her family deemed her never likely to marry. So, you know, sort of the narrow thinking of the day. And so eventually she immigrated to England to join her brother, William Herschel, in 1772. And at first she was just his assistant and kind of housekeeper. Of course, she would do stuff during the day for him, typical stuff of the day. But at night, she would, take notes as he observed through the telescope. But eventually, she used another telescope that Herschel built for her. Her brother built for her, and between 1786 and 1797, discovered 8 comets. So again, that was more than anyone at the time. And in 1787, she was granted an annual salary of £50. I guess that may be a lot for the day, by King George III. So this makes her the very first paid female professional astronomer in history. So good for her. So she made out a pretty decent career for herself. All right. So how we doing here? So we're not quite halfway in here. So while we're waiting here, let me give you a little upcoming preview of what we got going on. So first, if you do live in one of these counties in red in Southwest Michigan, so that of course includes Kalamazoo County and the surrounding counties, plus Kent County, because there's a major population center there called Grand Rapids. You can join the Kalamazoo Astronomical Society and use the remote telescope. We do occasionally grant people access to the telescope that live outside the area, but it's usually people that lived in our area for a long time but moved away, or were members for a long time in the past, something along that line. It would have to be special circumstances to let people outside the area use the telescope, because currently we have roughly 40 members that paid to use the telescope. Maybe half that use it on a semi-regular basis, and about a half dozen of us use it as much as we can. So the past month or so, the scope has been booked every night just by local members. So so far the scope hasn't been ignored too much to try to branch out to other areas and let people use it. But who knows? And so, of course, someone mentioned our online viewing session schedule. Of course, we're almost done with the first night here, and we're going to try again for December 5th. But part of me is kind of hoping we have to delay another week, because December 5th is like 4 days after a full moon. So toward the session, we might have the full moon to contend with, or at least the waning gibbous moon. But perhaps we'll have to delay. Last year, we did these sessions, of course, in person, and we had to postpone half of them, but we never canceled. We did all 4 of them. And and by the way, people might be thinking we're doing the online sessions this time because of the virus. We are not. Last year we did it in person because that's what some people wanted to do, and it was a modest success. It kind of went okay, but I realized with an online session we could open it up to a lot more people. So that's why I spent time contacting well over 300 clubs in the US and Canada, and it paid off in terms of registrations, but hopefully we can get more people to turn out next time. But I guess when you delay, that throws people's plans out the window. So be sure you do join us on December 5th. You can go to our website and register right now for the December session and all the sessions for the rest of the season. You can register from the schedule page. You can scroll through the event horizon on the main page. And you can also go to the online viewing session page located under the activities tab and scroll to the bottom toward the calendar and look for the registration links. So go ahead and register right now. Don't keep me waiting. And you're also welcome to join us for our December general meeting. We are, of course, holding these in person or online, I mean, because of the virus. So that means, again, anyone can attend. Anyone anywhere in the world can join us for a general meeting. Of course, if you're part of another club, you have your own general meetings, but we do have a special guest speaker, Dr. Emily Levesque from the University of Washington will present a presentation by the same title of her new book, The Last Stargazer. So we're looking forward to that. We're going to be doing a 5-part lecture series here soon called The Introduction to Amateur Astronomy. Again, there's full details on our website, and you can go to the the AmAstro website, as I call it. Also located under the activities tab to register. I am the one conducting that series, but hopefully we'll have a few members help me from time to time. And if you think you're above a introductory to amateur astronomy series and want something more in depth, I'm offering a 12-week college level course on astronomy that begins a little earlier on January 12th, because the lecture series begins on January 23rd. So this is a full-blown college level course in astronomy. And you can find a link to the syllabus from the main page of the website. Just wait till you see a slide like this one, click on it, and you'll see the syllabus. There is a fee for that, of course, because it's twice a week for 12 weeks. And so learn more from the syllabus and contact me directly if you want to register, because we currently have 22 people signed up. So the class is definitely going to go forward. And I'll bring the slide back here later. So let me hop back to the browser, and we're all done there. So there it is. Ooh, pretty. So I love this thing. So look at that sucker. Oh, beautiful. So NGC 253 is 91,200 light years in diameter. That's by my math, because I could not find a quoted distance online. So I used the angular diameter and its known distance and did a little trigonometry to get a diameter of 91,200 light years. And so if my math is bad, I'm sorry. So it does appear to be a somewhat barred spiral galaxy as well as a starburst galaxy, which means it's making stars at a prolific rate. So usually if you're a starburst galaxy, that means you had a close encounter or a direct collision with another galaxy. And it's been a starburst galaxy for the past 20 to 30 million years. And you may have read that the Milky Way contains a supermassive black hole at its center. That one is about 4 million solar masses. This one has a supermassive black hole somewhere in there at about 5 million solar masses. So it's a little bit more massive than the one we have in the Milky Way. So pretty typical. And NGC 253 is part of the Sculptor group of galaxies, which contains about 13 galaxies. And it is one of the closest to the local group of galaxies that contains the Milky Way. So the local group, the Sculptor group, these are what we call poor galaxy clusters, because they have usually fewer than 100 members. There are also rich galaxy clusters that have thousands of members, like the Virgo cluster of galaxies. So there we go. And of course, I was hoping we would have time to download a few images tonight and look at them up close, but we didn't really seem to have quite enough time for that. But we do have roughly about 10 minutes left. But if anybody wanted, we could do maybe a request or two. Probably at least we got time for one, or at least a few more questions. But I wanted to leave 253 up there a little bit longer. So yeah, so I really like that galaxy. So you can see why it's called the silver coin galaxy. It does look like a big giant kind of coin on its side. All right. All right, so let me go. Oh, so of course someone asked where you can download the images tonight. So let me go back to the PowerPoint slide there. If you are part of the online viewing session email list, you have this link already. And of course, if you're a KAS member, I shared it with you by email as well. So if you are not a member and you're not already on the online viewing list, just go to our contact page and contact us through that and tell us you want to join the email list. There's even an option in the pull down menu to select put me on the online viewing session email list, and you don't have to write this down. I'll send it to you in a link. So of course you can go to this link right now and you'll just get like a big error because, you know, I just took the pictures, for goodness sakes. So I haven't had time to even download them yet, let alone do some quick processing on them. So you can enjoy them. So do a screenshot, write it down. You can always email me or join the email list. And there's where you'll find the files that we took this night. I can bring that back up there later, or maybe someone could cut and paste it into the chat. There we go. All right. So I see someone, Eric already cut and pasted it in there. He's coming in handy already as a new member. So yeah, NGC 891 is not a reference to WMU 89.1 FM. Sorry. The galaxy was discovered long before the radio station came around. Let me scroll back here. I think I saw some of these already. All right, so Anne asks, can you suggest a tracking or drive scope for personal use? So if you want a equatorial mount that can track, you know, and don't want to spend a lot of money, there's like a gosh, what do they call those Celestron mounts? The Roger, you know, because you have one. They're the Celestron VX equatorial mount. We'll have to unmute you there, Roger. We still can't hear you, Roger. So basically there's mounts from Celestron that you can use. Some of them aren't terribly expensive. There are all kinds of all azimuth mounts too, if you don't like working with an equatorial mount. So John asked, yeah, the roof is controlled remotely because currently Mike Patton is right here. You can see his name. At least he's not sharing video, but Mike Patton is still in Michigan, and he'll be traveling out west for the winter next week. So yeah, the roof is totally remotely controlled. So we don't have a person there to roll off for us. Or if we can't close it from here, we'll have to call one of the neighbors in a rush to see if they can close it. But it's not supposed to rain there anytime soon. Like the next week out there is supposed to be clear. So hopefully you got the link to download. Yeah, so Lost Manny Titan mount's a really good mount. That's what you got in the observatory there, I see, John. So, well, we only have 4 more minutes, but of course, we're just getting started. This is only the first session. Hopefully you enjoyed the presentation. I'm still a little rusty on my timing, but again, we haven't done these since really February. So I'll get better, I promise. And I hope you had a great evening. And don't forget, you can download the images hopefully maybe tonight. I'll try to maybe get to it tonight, but most likely tomorrow. Any last minute questions or anything? Or anybody want to just chat in general? If not, we'll hopefully see you soon. Don't forget, general meeting on December 5th or 4th, something like that. The 4th or the 5th, I forget which already.
I just want to say thank you. This was great.
Great, yeah, I'm really glad you enjoyed it.
Thanks so much for the presentation there, Richard.
Something a little
Appreciate
different,
it.
right? There's something a little different to do because it is cloudy here right now, so there's no chance of going out and observing. Maybe you got clear skies there in Arizona, John, but we don't. It is very cloudy.
It's raining here. Great job. Thank you.
Yeah, thank you.
Thank you so much, Richard. Goodbye, everybody.
Bye, Jackie. Bye, Dick.
Florida too.
They're now in Florida, so we do have some people from Florida.
It's
And-
raining here too.
That's it. And if you have not mentioned where you are in the chat yet, please do. I don't think I have it set to save the chat when I close out. So shoot, I'll just have to scroll through them here. Because I was going to mention that. Is there a way to save the chat? No, I don't think so. Oh, well. Live and learn. All right. Hello, Don. I see you waving there. We can unmute everyone, I guess.
Richard, there's a 3-button tool next to file under the chat that can save your save chat.
There you go.
Oh, I see it.
Save the chat. That's
All right. It says chat saved. I'm sure it's in the Zoom folder. Great. Because I am not.
You can also copy and paste, which I just did.
Yeah. All right. I'm going to go ahead and end the YouTube live stream here. So if you're watching on YouTube, I hope you had a great night. I never had a chance to really look at YouTube. I kind of forgot to do it to see if we had people watching on YouTube there.
You need to get a co-host for that.
Yeah.
Yes, we do.
We
have
had
someone
31
there,
people
so we
on
must